Welcome to the mathematics in my channel. Today we are going to solve another interesting integral from 0 to 1 x to the minus x times natural log of x to the minus x dx. Okay, first we know the integral of 0 to 1 x to the minus x is a Sophomore's dream. So in previous videos we discussed about Sophomore's dream and we generalized the Sophomore's dream integral. So in previous video we solved this type of integral from 0 to 1 x to the x dx, also integral from 0 to 1 x to the minus x dx, and integral from 0 to 1 x to the square root of x dx, integral from 0 to 1 square root of x raised to the square root of x dx, and integral from 0 to 1 x to the third power dx, like this. So if you like, watch these integrals. I will add the link in the description and also make a card. Okay, now today we are going to discuss about this integral. So what can we do, how to start? Okay, first I'm going to define a function f of a. F of a is equal to, I'm going to take integral from 0 to 1 x to the minus ax dx. Okay, then we know x is equal to e to the natural log of x. So we can write x to the minus ax is equal to e to the minus ax times natural log of x. So we can substitute here. So we can write integral from 0 to 1, instead of x to the minus ax we can write e to the minus ax natural log of x dx. Okay, then we can use infinite sum. So we can write here integral from 0 to 1 infinite sum n is equal 0 to infinity minus ax times natural log of x to the n power over n factorial dx. Okay, then we can switch the integral sign and sigma notation. So we can write here n is equal 0 to infinity. Now we know here minus sign, so minus 1 to the n power, minus 1 to the n power, here a to the n, so a to the n over n factorial. We know these are constants, so we can write outside of the integral sign, and here integrals from 0 to 1 x to the n times natural log of x to the n dx. Okay, then we should evaluate this integral. To evaluate this integral we can use a substitution. So if we take u is equal to minus times natural log of x, then we know we can isolate the natural log of x. So natural log of x is equal to minus u, then x is equal to e to the minus u. Okay, now we know u is equal to minus times natural log of x. Now I'm going to take differentiate. So du is equal to minus 1 over x dx. Then we can isolate the dx. So dx is equal to minus x times du. Then we know x is equal to e to the minus u, so minus e to the minus u du. Okay, then we should change the lower limit and upper limit. So we know when x approaches to 0, u approaches to minus infinity, so infinity. Upper limit when x approaches to 1, u approaches to 0. Okay, then we can write now our integral is equal to infinite sum n is equal 0 to infinity minus 1 to the n power times a to the n power over n factorial. Now limit, we know infinity to 0, infinity to 0. Now here x is equal to e to the minus u. So we know here e to the minus u, but here x to the n power, so e to the minus u n times. Now here natural log of x we know minus u, so minus u to the n power times. Now dx is equal to minus e to the minus u du. Okay, then next step we can write infinite sum 0 to infinity. Here minus 1 to the n power, and also here minus 1 to the n power, so we can write minus 1 to the 2n power times a to the n power over n factorial. Now we can change the limit, lower limit and upper limit, from 0 to infinity. When we change the limit, this minus get cancelled, and now we have here e to the minus u and here e to the minus u, so we can take minus u as a common factor, so e to the minus u times n plus 1 power times here u to the n du. Okay, then again we can take a substitution. So if we take u is equal to, u times n plus 1 is equal to t, then differentiate n plus 1 du is equal to dt. So we can write our function f of a is equal to 0 to infinity. Now minus 1 to the 2n, we know 2n is a positive number, so here 1, so here we have only a to the n over n factorial. Now limit also 0 to infinity. Now e to the minus u times n plus 1, we know minus t times, now u to the n, u is equal to t over n plus 1, so t to the n over n plus 1 raised to the n plus 1 power times du is equal to dt over n plus 1. Du is equal to dt over n plus 1. Now we can simplify. So here infinite sum 0 to infinity a to the n over now here n plus 1 raised to n plus 1, here n plus 1, so we can write n plus 1 raised to the n plus 1 power times 1 over here n factorial times integral from 0 to infinity. Now here we have e to the minus t t to the n dt. Okay, now we know now this is equal to gamma of n plus 1, gamma of n plus 1, we know n factorial. So we know now this n factorial and this n factorial get cancelled, and now we can write this is equal to here n is equal to 0 to infinity. Now if we take n is equal 1 to infinity, here we can write a to the n over n raised to the n. So we can write in the numerator n to the minus n. So here we have f of a. Okay, now if we take f of 1, so to get f of 1 we can substitute 1 for a. So f of 1 is equal to integral from 0 to 1 x to the minus x dx, and we know this is equal to n is equal 1 to infinity n to the minus n. Okay, now we know integral from 0 to 1 is equal to infinite sum n is equal 1 to infinity n to the minus n. Okay, now this is not our question, but we evaluated f of a. So we know f of a is equal to integral from 0 to 1 x to the minus ax dx, and this is equal to n is equal 1 to infinity a to the n to the minus n. Okay, now to take our integral, now I am going to differentiate with respect to x. So here f dash of a is equal to integral from 0 to 1. Now here x to the minus ax times coefficient of a, so minus x times natural log of x dx, natural log of x dx, and we know this is equal to now here this side n is equal 2 to infinity n to the minus n. Here sorry, here I did a mistake, sorry again. Here f of a is equal to when n is equal to 1 to infinity, we know n to the minus n, a to the n minus 1 power, a to the n minus 1 power, then we can plug in 1 for a. So here we know this is correct, and here now n is equal to infinity. Here f of a is equal to here also n minus 1, here n minus 1 power, here n to the minus n. So now if we differentiate here n to the minus n, now n minus 1 times a to the n minus 2, a to the n minus 2. Okay, then next step, f dash of a is equal to integral from 0 to 1 x to the minus ax. Now here we can write this is equal to natural log of x to the minus x. According to property of natural log, we can write natural log of x to the minus x dx, and we know this is equal to n is equal to infinity n to the minus n minus 1 a to the n minus 2. And now again I am going to substitute 1 for a. So here f dash of 1 is equal to integral from 0 to 1 x to the minus x natural log of x to the minus x dx is equal to here we know n is equal to infinity n to the minus n times here we know this is 1, so n minus 1. Okay, this is the answer for this question. If you like this video, please subscribe this channel. Thank you for watching.